Good day, guys. You are welcome back to ID Mathematics class. I want to introduce you to a new section on this channel, which is going to take care of UTME mathematics for those of you guys that will be writing mathematics in your UTME. And I will take you through all the possible topics that will be tested in the UTME mathematics examination. And I wish all of you good luck. We are starting straight away with probability. What is probability, by the way? Probability is a measure of likelihood. Probability is otherwise defined as number of required outcome all over number of possible outcomes. Terms in probability. We have the following terms in probability which you must understand perfectly before facing questions on probability. We have this not, both, or, and, at least, at most. What do we mean? In probability, not means 1 minus probability of that thing. If it is not A, probability of not A, it will mean 1 minus probability of A. You will see the application when I give you example. Both is used when two elements are being referred to. We use both, and it suggests and. Why and itself means multiplication in probability or means addition. Now, the word at least means from that item and above. At least, let's say at least 5. It means 5 and above. 5, 6, 7, and so forth, depending on what you have in the data. At most 5 means 5 and below. 5, 4, 3, 2, downward like that. So that's the interpretation of at least and at most. Let's see how to apply them in example. So let's consider this example to substantiate what we are saying. A crate of soft drinks contains 12 bottles of Coca-Cola, 3 of Fanta, and 9 of Sprite. If 2 bottles are chosen at random without replacement, find the probability that they are both Fanta. So, total number possible here that we have is 24. Our required item here is 2 bottles of Fanta. Find the probability that they are both Fantas. That the 2 bottles chosen are Fanta. So we say probability of that both are Fanta will be the probability of choosing the first one will be number of Fanta, which is 3, over total possible outcome we have there, which is 24. And the probability of choosing the second one will be 2 all over 23. How? In the group of Fanta, we have 3 Fantas. 1 has been taken away. Definitely 2 will be remaining there. In the whole crate of 24, 1 has been taken away. That same Fanta has been taken away. 23 will be remaining there. That's why we are taking the second one, it will be taken on 2 over 23. The hand is multiplication, so we have 3 over 24 times 2 over 23. Here, 3 in 3 is 1. 3 in 24 is 8 times 2 over 23. Coming here, we have 1 over 4 because 2 in 2 times 1 over 23. Do you understand? 2 goes in 2 ones in 8 4 times. So 1 times 1 is 1. 4 times 23, that is 92. And that is the probability of choosing 2 bottles that are Fanta without replacement. If it were with replacement, it will be 3 over 24 times 3 over 24. We take it, we replace. We take one again. But now, these two being chosen out of them is without replacement. That is, when we take the first one, we don't replace it. Then we take the second one. That is it. I want to believe you understand. Let's consider another example that we make use of another time. Let's consider this example 2 under this general explanation of the terms in probability. The table below shows the scores obtained by 20 students. This is the table. Find the probability that a student selected at random scored, room of figure 1, 40 or 60. How do we use or in that regard? Room of figure 1. Probability of 40 or 60. Probability of selecting a student that scored 40 or 60 marks will be equal to the number of students that score 40, that is 5, all over total possible outcome, which is the total frequency, which is 20, plus the whole is always addition in probability. 60 marks. How many students score 60 marks? 2. 2 over 20, which is 7 over 20. And that ends that. Let's consider Roman figure 2. Find the probability that a student selected at random scored at least 50 marks. Probability of at least 50 marks is, we look for the numbers of students that scored 50 and above. At least means that number and above, as I've explained to you the other time. So those that scored 50, 60, and 70 are qualified to be there. At least 50 marks means 50 marks and above. And how many students score 50 marks and above? That is 4 plus 2 plus 1. That is 4 plus 2 plus 1 all over 20. You know, you could have it as 4 over 20 plus 2 over 20 plus 1 over 20. But at the end of the day, it will be like this. You work it out like this. And the answer is 7 over 20. Wow, what a coincidence. The answer is 7 over 20. Now, Roman figure 3. Probability of at most 40 marks equals those that scored 40 marks and below. That's it. 40 and below. That is. And how many students are there? 5 and 8. That is 13 over 20. And that is it. Is the answer of that. Roman figure 4. Probability of not scoring 60 marks. What does that mean? I have told you probability of not A means 1 minus probability of A. So probability of not scoring 60 marks means 1 minus probability of 60 marks. So what's the probability of scoring 60 marks? That is 2 as the required number of students that scored 60 marks all over total possible outcome 20. 2 over 20, which is 1 over 10, which is in turn 9 over 10. And that's hence this introductory aspect of terms in probabilities. So I will now go into full explanation by examples using past questions. This is just the background examples and explanation of the terms in probability. So anywhere you see not, remember it means 1 minus probability of that thing. Both refers to two items which eventually result in the use of and. Or means addition, and means multiplication. At least 5 means 5 and above. So any figure that is there, any value that is there, at least that value means that value and above. At most 5 means 5 and below. If any value different from 5 is there, it means that value and below. So that is where we are going to stop on this aspect. We now move into examples using past questions. Now let's consider example 1. This is one of the past questions of the same UTME mathematics. So, two numbers are removed at random from the numbers 1, 2, 3, and 4. What is the probability that the sum of the numbers removed is even? I want to believe you know even numbers, and if you don't know even number, I will explain succinctly here, and I want to refer you to the junior section, specifically junior class 1, JSS1 section on this channel. Go there to go and learn more about numbers. It is well expatiated there. Now, to attend to this question, what are we expected to do? We are given 1, 2, 3, and 4, and 2 of them are removed at random and added together. What is the probability that the sum of the numbers removed is even? When we take 2 of them and add them together, what is the probability that the sum will be even? Then we do this. First, 1, 2, 3, 4. We take it here as well. 1, 2, 3, 4. If we take this 1, 1, 1, 2, 1, 3, 1, 4, 2, 1, 2, 2, 2, 3, 2, 4, 3, 1, 3, 2, 3, 3, 3, 4. Then 4, 1, 4, 2, 4, 3, 4, 4. So what do we mean? Where do we have the sum of the two numbers being even? The sum of two numbers here is even, 1 plus 1. But these, according to the question, the two numbers must be two different numbers, not two same numbers. Though it is not said in the question, read the question. Common sense dictates that the two numbers being referred to here are not the same. It's not 1 and 1. It's not going to be 2 and 2. No, it must be two different numbers. Two numbers out of 4 numbers. That means they must not be the same. So this ring must not be tampered with, where we have same number. This, where we have same number, must not be tampered with. We now look for elsewhere where two numbers give us even, form even numbers, like 1 plus 3 give us even number, because 1 plus 3 is 4. 4 is an even number. Also, 2 plus 4 forms even number. 3 plus 1 forms even number. 4 plus 2 forms even number. And I think that is all. Let's look at it together. That is all. So we have only 4 cases of such. Then this thing is what we call sample space. Sample space. And that sample space means combination of the possible cases. So the number of sample space is 1, 2, 3, 4. 1, 2, 3, 4. 4 times 4 is 16. If you count them one by one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. The number of sample space here is 16. And that is what constitutes our possible outcome. Don't forget, we say that the probability means number of required outcome all over number of possible outcome. The number of possible outcome here is 16. The number of required outcome is 4. 1, 2, 3, 4. Required. What is required? Two numbers whose sum form even numbers. And that is it. Number of required outcome is 4. Number of possible outcome is 16. We say, therefore, probability of that event is number of required outcome, which is 4, or over number of possible outcome, which is 16. Reduce to the lowest term, you have 1 over 4. Therefore, option D is going to be the correct answer. Let's consider example 2. Find the probability that a number selected at random from 41 to 56 is a multiple of 9. Two things are notable there. Number 1, the number of the elements we have from 41 to 56. Number 2 is multiples of 9. What is multiple of 9? Multiple of 9 refers to all numbers that are exactly divisible by 9 without any remainder. So 9, 18, 27, 36, 45, they are multiples of 9. Now, from 41 to 56, how many numbers do we have? We have 16 of them. If you subtract 40 from 56, that's a method to quickly get their number. Don't subtract 41 from 56 because 41 is inclusive. Therefore, subtract 40 that is not inclusive from 56, you get 16. So we have 16 of them there. So how many among those 16 are multiples of 9? You can see from 41, 42, 43. In the exam, you don't need to list them all like this. I will list them all, but you don't need that. In the exam, what do you need to do? Just quickly note which of them are multiples of 9. You see, 45 will be multiple of 9. 54 will be multiples of 9. How? You know that from 41, 42, 43, 44, 45 is a multiple of 9. Add 9 to that 45, it gives you 54. It will give you another multiple of 9. If you now add 9 to 54, it will give you a number greater than your boundary. The 56 is the boundary in this case. So these are the only two numbers that are multiples of 9 among 16. Let's say we list them all up to 56. Only these two among the 16 are multiples of 9. What's now the probability that a number selected at random from 41 to 56 is a multiple of 9? Two numbers are multiples of 9. And probability is number of required outcome all over number of possible outcome. So, with this, what is the required outcome here? The required outcome is multiples of 9. What is their number? Number of required outcome. Number of them is 2. Only 2 of them are multiples of 9. So we have 2 over. What of number of possible outcome? The number of possible outcome here is the total number present here from 41 to 56, which is 16. So that is 16. Reducing this to the lowest term, 2 in 2 is 1. 2 in 16 is 8. Answer will be 1 over 8, which is option A. Let's consider example 3. A number is selected at random between 15 and 23. Find the probability that the number is a prime number. First thing to do, let's have the number of the items we have between 15 and 23. We have 15. Build a wall. We now have 16, 17, 18, 19, 20, 21, 22, 23. See the way I create the wall. That means 15 and 23 are not part. They are not supposed to be part because of the language between. Take note of that language, very important. So 16 to 22 are the numbers between 15 and 23. Therefore, number of required outcome. Number of required outcome will be the 17, which is prime number. 19 is prime number. How many are they? 2. Number of possible outcome. That will be 1, 2, 3, 4, 5, 6, 7. 7. Don't forget probability of that, I don't want to be wasting our time by putting something in this. We are dealing with objective questions, so we don't need to be writing that kind of epistle. The probability will be equal to number of required outcome 2 over number of possible outcomes 7. So the correct option will be option C, as you can see. But if you don't have that knowledge and you include 15 and 23, let's see whether you have a chance of being deceived in the options. Let's see, if you include 15 and 23, your own number of possible outcomes will be 9, while your number of required outcomes will be 3 instead of 2, because 23 also will be included. It's a prime number. So you will now have 3 over 9, and 3 over 9 is 1 over 3, which is option B. See how cheaply you would have been deceived. Therefore, take note of it. Once you see the word between, the two hens will not be included. And the question that we want you to include them will include a special word, inclusive. I will show you example of that from past question as well.